Hello, everybody. We'll start in about 10 minutes. Yes, I know the camera's off. Now it's on. Now it's off. So, yeah, I'm just going to chill for a second and get ready. We probably won't really do pre-stream questions today, but we'll do post-stream questions for sure. Yes, that's about 10 minutes from now. Some of us were never on GitHub, so we don't have to migrate off GitHub. Should we do the eye tracker for the demo or not? I kind of am in the mood to try the eye tracker. See if it's working. Not seeing a damn thing. Okay. Nothing is happening. Apparently, don't unplug it from the USB. I don't know. It just doesn't work if you unplug it from the USB. Maybe we aren't. Oh. I'm clicking improve calibration and it doesn't work. Okay, if you have one of these, don't ever unplug it from the USB because it'll stop working. Improve calibration, bro. This is what happens when you try to glue programs to other programs. Like it's trying to start something and it's just like failing to launch. Do you need an eye tracker for an official demo? It's a good question. Probably not. You know what? Let's go without the eye tracker this time because I think the good function of the eye tracker is, you know, for long periods of when the programmer is sitting there and thinking, you know. I think for an official demo, it's not so important. Yeah, I'm not a big fan of the Unix philosophy in the year 2018. I don't think it worked very well, and I think that's obvious. To anyone who's willing to actually assess. I'm sure I've ranted about the Unix philosophy being bad before. I would just have to find the video clip on YouTube somewhere. I need to make a frequently asked questions of those. All right. Let me get a snack ready and then we'll go. Well, the viewer count is still going up, but it is 7:06, so I think we start imminently. I think people who are late, and that's just how it is. How long is it going to be? I don't know. I have no idea. Hopefully short. We'll see. Well, thanks everybody for showing up tonight or today or this evening, wherever in the world you are. It's been a while since we've done an official presentation like this. Probably, I think, since February. So that's about 4 months. So part of what I thought I would start with is just to describe what's been going on for the past 4 months. A lot of the work that I've been doing on the compiler has been about fixing bugs and structuring internals to find cleaner ways to do the things we were already doing. Just continually making the compiler simpler and better at what it does. Because, you know, we're building a language with a lot of features, and those features interact with each other. And if you let too many weird bugs and corner cases stay, then you create complexity in the interactions of all those corner cases with all the other things. So we're trying to smooth it out, iron it out, make it good, not be in too much of a hurry to release it out to people. Well, I don't really need to say more about that. Anyway, so there's been lots of internal restructuring, lots of bug fixes. People who have been tuning in for the live streams we've done in the past couple weeks have seen a lot of that. Although, you know, we went for several months without doing too many of those streams, but you can extrapolate, those of you who have seen those. We've also been doing a lot of work on the Sokoban game, which is the biggest application for the compiler. It's about 77,000 lines of code right now, which is substantially bigger than the compiler. It's not a direct comparison because this number includes whitespace and comments. And generally, when we word count on the compiler, it doesn't, which, by the way, let's do that. Well, let's go. So the compiler is around, 42.3 right now, 42,000. And this 77,000, if you remove the white space and comments, is probably, let's say, mid 50,000s. I don't know. So it's bigger than the compiler. And a lot of that is just stress testing the language features, making sure they really work, figuring out what features we need and what the ongoing concerns should be when we move forward and add things to the language semantics. So we have not been adding things to the language semantics really since February, but we're getting to the point where it's time to do that soon. So the plan is that the next demo will have a big feature in it. But today is more about the smaller improvements that we've been doing over these months at the same time that we've been doing all this bug fixing and stuff. The current status is that we now have about 4 people working on the compiler and the game full time. We sort of go back and forth on either of those. Abner has been putting together a bunch of notes on the really old demo videos and some example code and introductory types of materials, for people who might want to learn how to program in this language. And my original thought was that we were going to hold that stuff back until the initial, closed alpha release with a limited group of people. But from I've been reading the temperature on streams and stuff, and it seems to me like people would really like to have some of that just so they can fill in their own knowledge and stuff, even if they don't have the compiler yet. So we're going to be making that stuff available pretty soon. I don't have a specific date on that. It'll be, when we think it's ready, but hopefully pretty soon, before the next demo for sure. Turn on a light in here. I don't know why it's so dim. Sun's going down on me. All right, so let's move on and show some things. The first thing is that, well, to fill in some very brief context for people for whom this is new and haven't been following along, but also to keep it very, very short because I don't want to bore people who have been following along, right? When you start up the compiler, you actually start up a meta program which has, it's a complete program and it can do anything that you want. It can organize compilation, it can modify the program that you're compiling, and so forth. And there's many demos of that on YouTube if you would like to go back and look. So one capability that we didn't have until now, and it's just that we didn't get around to it, was there was no real way of passing command line arguments to that meta program. It just did what it did, and we would sort of, if we wanted to make the meta program do different things, we would maybe just go into it and change some strings or something. But now there's an official way to pass command line arguments to the meta program. And I'll show what that looks like in the command line in a second. But the way you get them is you just call this routine compiler get command line arguments, and that returns you an array of string. And here we're going to print out what arguments were passed and then what the command line was. And if I run today's demo, it's called Demo June MISC. It's going to have a lot of output because that's how we roll. But if I go up here, so you see 0 args were passed and the command line is nothing. So now 0 args weren't passed here, but this is an option for the compiler. It's not an option for the user level. And you want to be clear about the separation between user level arguments and system level arguments because you don't want ambiguities, right? And so what we do is you just say dash dash and say, hello there, Mr. Creosote, right? Whatever, dash size 300. And anything to the right of that double dash, the compiler does not interpret and the user level does. So here we go, command line, hello there, Mr. Creosote, dash size 300. So that lets you communicate with the meta program, of course, without modifying it, which is a small thing, but really very useful. And so the way we use this in Sokoban, for example, is now when I'm working, I hit the F7 key, for example, to compile it. So there I've just compiled Sokoban and I can hit F5 to run it. That's not what we're demoing today. But here my F5 is now bound. It has dash dash x64, which says use the x64 backend, right, which is the faster one. I can say dash s LLVM, and wait, we don't have an LLVM. If I don't say dash dash x64, then we use the LLVM backend. I really should, just for the sake of consistency, do that. But there's also, you can control debug versus release build and all that by putting these options here, and then the meta program will interpret those. Someone is asking, why is there a distinction between the types of arguments? Just ease of use seems more flexible to pass all to both. Because you don't want to have to worry about what arguments the compiler... The reason for the design decision is just that you don't want to have to be confused about what's an argument for you and what's an argument for the compiler, right? So I don't know. If there's a reason why people maybe need to see the arguments before that, then maybe we can open it up, but it doesn't quite seem like the right decision to me. The other thing to know is that there aren't actually very many arguments to the compiler, right? We don't work like GCC or LLVM or Clang in that, those compilers control everything with command line switches. We control almost nothing with command line switches because I don't think that's a good way to do it. We control everything through build options through the meta program, right? Which the thing that's reading these arguments is the meta program and is what has control over those things. And so I don't really feel like there's much utility in passing the compiler arguments to you, and it feels dangerous. But, it's very easy to change the implementation to work either way. The thing I'm just trying to illustrate now is that that works. Okay, so Well, as I've said, we have this compile time execution engine that runs your metaprogram. And, you know, people were tossing around the idea of using that as a scripting language, because that's essentially what it is, even though it's exactly the same programming language that's compiled. And someone on the team said, hey, why don't we support hashbang so you can just run this like a script? And I was like, my initial instinct was like, ugh, we don't want to do that. But then I was like, oh, maybe it's a good idea. And I'll explain the rationale at the end of this, but first, why don't I just show how it works? So this file is demo June MISC, and at the top of the file, we actually have a hashbang and some stuff, and then some options. And well, if you run this from a Unix-like operating system, then this is where this would be installed, and you could run it as an executable there. The from hashbang argument actually tells it, well, this dash dash starts the user level options, but because this is running from hashbang, the operating system is going to put the file name over here. So pull the file name off and compile that, and then go, right? On either operating system, right, on any operating system, we treat a line starting with hashbang as ignored, right? So that's why I can compile this program. Yeah, you know, and we just skip past the fact that there's this hashbang, and it doesn't have to be the first line of the file. It could be any line of the file as long as it starts at column 0. And the rationale behind that is just, you know, well, maybe you want to be able to concatenate files together without thinking about it or something. You know, that's a minor detail that we may change. So hashbang is generally on a Unix-like operating system how you would make this thing run in the compiler if you click on it or just run it from the command line, right? In Windows, that works differently, and I'm demoing on Windows right now. So in Windows, if I do this kind of thing through file associations. So if I go to our demos folder, I've right-clicked on this earlier and added a file association. Actually, I added it through an external program. And so if I click on this, it actually runs it now. It runs the compiler with an argument that says, hey, pay attention to the hashbang at the beginning and get the arguments from that, right? And so what this actually does is it looks at this up here, and it says, well, let's grab these arguments off and then peel off the user-facing ones and just use those. So I'm saying hello sailor-sleep. And the reason I'm saying -sleep is because so that this window stays up. Otherwise, it would have disappeared immediately. But you see, we're running our whole program here. And I can do that just by clicking on it in Windows, right? So that gives you the ability to write little script-like things that work on Windows or on Linux, and that you can just click or run from the command line, right? So before, to compile this, I was doing all this stuff, right? I can just do this, and it runs now. However, that was the first implementation of this. And by the way, all of this is coming in super hot. This feature was built in the last couple of days, right? And someone is 1 minute ahead of the thing, right? So someone is saying, hashbang on Linux sends everything after the first space as a single argument, which breaks most apps invoked in that way. And yes, that is true. There's a table online. I should have dug up the link. But there's a table of like which Unix-like operating systems treat hashbang in what way, and it's gross. Like they all do slightly different things. It's a very unreliable system in general, right? Like, you notice how you have to have the path hard-coded here. It's because usually this doesn't do path search. And you can get around it by running a thing called env, but then that messes with your ability to pass arguments even more. In general, it's kind of icky. We have not today completely decided whether we're going to encourage people to put arguments here or not. We did an attempt at making that work, which is just if we detect that there's only one argument, and it has the string from hashbang in it, or dash from hashbang, then we do our own argument parsing where we break that into spaces. But then that's gross because you can't really have quoted file names with spaces or backslash spaces in here. But then people who are using hashbangs on Linux probably don't expect that, right? Meanwhile, on macOS, this will work fine. On recent macOS, this will work fine, and you'll get separate arguments. But on older macOS, it comes through as one argument, right? So it's gross. And we didn't realize how gross it was till we sat down to do it. So we still support this version right now where we go in and extract the arguments on Windows or on Linux. And the motivation behind that is just to make things work the same way. So you don't have to do a lot of operating system specific things. You can just drag your files over and use them. That said, there is a way that I think is cleaner and works better and doesn't have all this grossness and potential landmines that happen when you use hashbang. And that is just, well, you can use hashbang, but just don't really provide any arguments. And we give the arguments another way. And so I have an example here of demo wrapper 1. I actually have 2 of these. But here I'm using hashbang, and we're just not passing any arguments. But we've added a routine called compiler set command line arguments that sets these user-facing arguments to whatever we want. And so here's some arguments here. It's just an array of string. And we import just enough to be able to do this. So we say, hey, set the arguments and then kick off this file, right? And so with this as a basic template, I can call into some later file with, let me go to demo wrapper 2. With different arguments. Let me line this up because this one doesn't have a comment. But you can see I've just got different arguments on this one than this one, but we're doing the same thing. And so this is how, for example, you could make some code base that does a lot of work with just different things that you click on or run from the command line that can do that with different arguments or whatever. And you don't have to deal with the hashbang nastiness because this is well defined and whatever. So this is the way that I would recommend doing it if you want to be maximally robust. But maybe, maybe it's the case that using these arguments is just more convenient or something. We're going to see how it shakes out. Right now we support both. So for example, here I can say demo wrapper 1. And if we scroll up to the arguments thing, we say, hey, the command line was hello sailor -sleep, right? And that's what we gave here. Now, of course, I have this folder over here with some shortcuts in it. And just to show, I can just click on these. So here's demo wrapper 2. And the arguments are wrapper number 2 -sleep. Yeah. So 2 different ways of doing the same thing. The upshot is now that you can go all the way out to the shell and just make things that you can click on or run. Okay. So like I said, when we first talked about doing that, my initial reaction was like, yuck, that's kind of dirty, right? But it does solve one problem, right? And the problem that it solves is expanding the scope of what you're able to do without having to use external tools that may change from operating system to operating system, and that you have to have different mechanisms of doing, as people work on the different operating systems, right? The people have to learn how to use them differently in different places or whatever, right? One of the founding theses behind this compiler is that you don't want to do that. You don't want to have these weird tool chains, right? So a language like C++ doesn't specify how to compile itself. It's just a bunch of .cpp and .h files. And so you have to have this whole other system for organizing those and deciding how they get built and deciding how they get put together into a program. And that stuff changes on every operating system, and those changes are a big headache. They're annoying, right? The whole idea has been, let's make those not be necessary at all. Like if there's some tool that you want to use on a particular operating system, that's great, go ahead and use it. But the language is going to be self-sufficient enough that you can just use it and do the things that you want to do, right? And so now one of the things that you can do is just have shell-like things that you can click on. And that is now all completely spec'd within the programming language, and so it's guaranteed to work, right? To the extent we can, right? I mean, there might be some operating system where you just can't click on things. And then what can we do, right? But, but if you're able to set up a file association, or if you're able to use hashbang, then this will work. OK, enough about that. Where are we next? Error coloring and lexical ranges. OK, so when I run this, you'll notice before this output that we're seeing, we're actually getting some warnings as we compile. These warnings are intentional. We'll get to the part in a minute that causes them. But you'll see now that our error text is colored, and the thing causing the error is highlighted in a different color. It's more readable than our previous error messages, first of all, due to the highlighting. And second of all, we now have ranges, like a lexical range of a starting character and an ending character of what the thing is that caused an error, whereas before we just only had one character. So we had a weird like pointer that kind of pointed you at where an error was, but would often be, you know, at the end of it or in a slightly confusing place, right? And so now we're starting to put in work throughout the compiler to generate better positioning for these kinds of things, right? So here, the type directive is the problem. So we have type highlight. Here, for example, I'm going to make a few different errors. So here's a polymorphic struct called thingy, which if you're a C++ person, this is our version of a template that takes parameters. So A here is a thingy of 10 float. That's not an error, right? B, I'm going to try make thingy of hello and int, and hello is not an int, so this won't work. Right? And so here we say, well, we give two errors for the same thing, but we say type mismatch, wanted int given string, and we tell you exactly what it is, right? So it's, those of you who have seen the error messages from before this week know that it wasn't quite as good as this, right? Here's one, you know, let's, instead of passing a type, let's pass a number. So, you know, literals as well, we get the whole literal. And for D, what was the error for D? Oh, thinger, right? So it's thingy and not thinger, so we typed it wrong. So it's just, you know, and what I would call a daily ergonomic improvement to your ability to read error messages and stuff. Now, Ignacio started using this, and he said, hey, man, I'm in an IDE where these colors look ugly, right? So you can say dash no color, and you'll get a black and white output. This color is from our own stuff, so ignore those colors. We'll see where those are generated in a bit. But here, now instead of coloring these type directives, we've just got these carets underneath, right? So about colors being ugly or not, you know, I found a very inconsistent ability to use 24-bit color. This shell that I'm using rounds everything off to like 9 different ANSI colors that are all ugly. So color support is relatively limited, but we might add a thing where we have different presets for different IDEs or something like that, or that lets you define your colors, just so you can make something that's not ugly. But this is just to show that the capability is there now, and the error messages are much easier to read than they were. Even if you're using the carets now, right, and you're not using the color highlighting, you still get the actual range of the thing, whereas before it would have been like one caret over here somewhere. It would have been slightly off. OK. With strings, we've added some escape codes and removed some other ones. So I want to go through what the escape codes are. So we've had \E standing for escape for a long time. I don't know if I ever demoed that, but certainly in some of the live streams when I was programming color output, I forgot that we had \E and I did it manually. But we do. So let me go to where we're defining these green normal, red normal. This is the code I'm going to look at now is what's generating this actually this color stuff. So we're printing out, I can print stuff in color anytime I want, and those are different colors, right? So we're saying I can print stuff in color anytime I want, and so green goes here, and normal goes here, and red goes here, and normal goes there. So we're just switching colors back and forth, and these green, normal, red, normal are ANSI escape codes. They start with an escape, ASCII escape, which is that \E, and then some code that is specific to this color encoding, right? So \E is one of the escape codes. Supposing you want to insert an arbitrary hex number, you can use \X and then a 2-digit hexadecimal code, which is what we're doing here. So this one says this is a test, right? So this is TEST. And here, this whole list of hex codes is printing out hello sailor, right? If you don't want to use hex and you want to use decimal, you can use \D and then 3 numbers. It's always 3 numbers, even if it's less than 100, 3 digits. So D000 is a 0-digit, right? D001 to 100, 101 to 102, 200, et cetera, and then ending in 255. And then because these aren't mostly ASCII numbers, I'm printing the bytes, right? So those are the bytes 0 and 2, 64 to 66, blah, 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 255 in hex, right? We printed the bytes in hex. So why do you want to do that? Well, sometimes you want to be very particular about what's in your strings, and this way you can do that. Well, what are some other ways to be particular about what's in your strings? Well, maybe you want to put Unicode in there, right? So just like C++ does, it's exactly the same format. You can say \u and a 4-character Unicode identifier in hex, right? This is, if you've ever looked at Unicode specs, these are like exactly the way that you specify specific characters. Now, UTF-8 or Unicode officially can, how do I say it? Unicode, I'm actually not that educated on the official Unicode spec, but in general, you manipulate 32-bit numbers behind the scenes, and sort of the maximum eventual range that Unicode might get to is considered to be all of that 32-bit space. But in reality, the highest currently defined Unicode value is like 0x20FFFF, or maybe it's 10FFFF. Anyway, it's more than 16 bits. But most of the things that you ever want to refer to are in the bottom 16 bits. So \u is like, yeah, this is one of these things from the bottom 16 bits, and I'm just going to refer to that. U is like, okay, I'm going to refer to something outside that, one of these more rare characters. And for today's currently defined Unicode, we could get away with 6 digits. But we're putting all 8, and so does C++, because the Unicode people are crazy, and they just keep adding stuff, and who knows how big it's going to get. So let's be forward compatible and just have all 8 digits for these rare cases when you need to use U. So this U2022 is a bullet point, and this is an upside down exclamation point. And so we say, I'm ready to make a slideshow with bullet points, right? We outputted that. And then this one is this 8-digit Unicode, which is a Chinese character that didn't fit in the lower 32 bits. This console doesn't have a font for that, but I can prove that that's what it is by pasting something into Google. So I can go here, and I'm just going to paste this into the browser. And you can see that that's a Chinese character, and it's giving me all these Chinese completions. So I don't know what any of this means. But yeah, we actually outputted that character successfully. Now, this is not necessary to use Unicode characters, because, as always, the input file is defined to be UTF-8. So if your editor supports UTF-8, you can just type UTF-8 in directly. So down here, we're using bullet points. It's just in the file, right? And if I'm in Czech Republic and I want to get some tea, I can say this, and I can use all the cool accents just directly in the file, right? And all of that, where's the output? All of that comes out correctly in the output. However, if you're using an editor that doesn't do very well with Unicode characters inline, or if you're manipulating characters that are maybe difficult in an editor. So for example, here are two arrows with a 0 width space in between them, because Unicode defines a number of characters that have no spatial extent and no visual representation. And that could be very confusing in an editor. So this is just a way to make clear that there is something there, right? So here's a 0 width space, blah. And you can see in the output that indeed these arrows have a 0 width space between them. OK, so the full list of escape codes in the language as of today are as follows. There's new line, carriage return, tab. Everyone's familiar with those, probably. Escape, right? 0 byte if you want to zero terminate a string for interactivity with C or C++ or any other language. Of course, you could do that with these. You could say X00 or D000, but it just seemed nice to have this little bit of terseness for good ergonomics of interfacing with those languages. Of course, just like C or C++, you can quote your quote, or you can backslash your quote or backslash your backslash in order to interface those. And then there's these new ones that we talked about today. And that's it. That's all of the string escape codes, right? We got rid of some of the weird ones from back in the C days, like vertical tab and form feed, which are mainly there for interfacing with line printers, but nobody uses anymore. So it seemed to me like a good idea to keep the list of escape codes very simple, so you don't have to be confused or thinking about 50 different things, right? Of course, if you want to insert a form feed or a vertical tab into a string, you can just fine, use the hex or decimal value, right? I'm not even sure about tab, frankly, because tab kind of sucks, but people might be porting programs that use it or something, and so we keep it there. Someone's asking, was there a point to \E? Yes, there's these escape sequences that control console properties like color and highlighting. OK, so let's get to that code that's actually generating those warnings that I said were intentional, right? So if you've watched any of the earlier demos or some of the live streams, you'll know that sometimes we had to use this directive called type if you wanted to use a type in a value slot, right? So let me rewind even one step before that and say, if you come from the world of C and C++, types are only used in those languages in very limited contexts. They're not regular values the way like a number is or a string is. But in functional languages, that's not the tradition. In functional languages, a type is a value just like a number is. And we are adopting the functional language version of this tradition. We have for the entire development of this language, or most of it anyway. But still sometimes, the parser wouldn't exactly know what to expect, whether it's a type or an expression, like a non-type expression. So we had this type keyword to help it along, right? So to illustrate how that used to be used, I've just made this polymorphic procedure. It takes some value that's a type, right? So it's of type. And we're going to instantiate a value that's of the type of whatever parameter we passed in. And we're going to say, OK, the type is whatever, and the default value is whatever. And here we're using our color codes again, right? So we get a bunch of output, like F says the type is S64, and the default value is 0. The type is some polymorph of thingy, and the value is an array of 10 float 32s, right? The type is an expandable array of S64s. Default value is this, and so forth, right? So we're just printing that kind of thing. Now, we're passing a type parameter to this. And the parser used to just expect a general expression there. So you would have to say type all the time. And you would get that was annoying, let's just say, right? we reworked the parser and or the semantic system to not require these anymore. So we can do all of these things now without saying hash type, right? So I can say f of thingy of 10 comma float. I can say f of array of int. I can say f of pointer to void, which also looks like take a pointer to a value, right? And all these things, array or pointer, relative 16-bit pointer to int, all these types. This is a very crazy, complicated type. And we get all the values. And we're printing them the same here and here. It's a little weird. I'm not sure why this is not 0. But need to look into that. Anyway, so that's just an ease of use thing. So that would come into play when you were calling procedures that take types, but it would also happen when you have structs that take types. So if I had a hash table, often you would make a hash table saying, well, I want to take a string as my key, and I want a pointer to an output file as the values that we store in the hash table. And well, you used to have to put type there, and now you don't have to do it. You just say pointer to output file, right? Now the way this works is kind of magic, because the parser, when it sees this, can't actually know if this is a type or a value expression, right? Or a pointer to a piece of data, is what I mean. It can't tell whether it's a type that's constant at compile time or a pointer to a piece of data that's not constant at compile time. So we have to make this determination during the type checking phase, right? We have to wait till we know what output file is, and then we can determine what the type of this whole thing is. But what makes all this possible is that the two sets of cases don't overlap, right? When you want to declare a type that's a pointer to some other type, well, that other type has to be something that's a type that is constant at compile time, right? And it doesn't make sense to take a pointer to something that's constant at compile time. So these representations didn't overlap, and that made that possible. And then for all these other things, mostly it's just a matter of rejiggering the parser so that they work correctly, with a little bit of exceptions there. There's one question of, is this so terse that it's confusing when you look at a program, and maybe you don't know what this is when you look at it? And my answer to that is we'll see, and we can always reverse this if we want. Maybe you have semantic highlighting in your editor that'll tell you if this is a type or not. I think that would be a lot more useful than syntactic highlighting, for example. I think a small amount of syntactic highlighting is useful, but the fruit salad that most editors put up is not useful. But also, I think even without an editor, you can pretty much tell from context what something is. Like if you name your types with capital letters or something as a convention, then you know this is a pointer to a type, and you're fine. Now, we haven't gotten rid of the type directive 100% of the time, and that's because if you're declaring a procedure type, well, a lot of procedure types we would be able to parse. So this is what a procedure type would look like if you got rid of this type directive, right? This we would be able to parse just fine, but the thing is, this thing, if you got rid of the type directive, would just look like this, right? So if I say this, this is shorthand for some procedure where we're not naming the arguments, but that argument is of type int, and it returns void, but you're allowed to omit void, right? So you're able to say just like int. You probably wouldn't do this in a real program, but grammars of programming languages are not about your feelings, right? So this would be, if you tried to take off the type directive, we don't know if this is just a parenthesized expression containing a type int, or if it's a procedure that takes an argument of type int, because we don't have a procedure keyword or token or anything like that. So in this case, and it's the only case as far as I remember that we still use type, it's to say, oh, the thing coming is a procedure type. And we might rejigger the procedure syntax a little bit to make it unambiguous. For example, if you said, well, OK, so the reason we let you do this is because if there's no body, or if there is a body, like you might be saying f is something and there's a body, right? And you don't want to have to say void, right? Or so forth. But the reason we let you not put the argument name is for cases when there's no body, like when this is a parameter to another procedure, right? Or a procedure pointer declaration. And so the idea might just be, well, if it's one of those latter cases where there's no body, maybe you just have to say arrow to something, and if you don't return a value, maybe you return void. I don't know. We'll look into it. But the point is, it's been very nice to get rid of this type directive almost all of the time. It's been nice. And we'll see if it's confusing, but I don't think it will be. Also along the lines of ergonomic improvements, we renamed some of the bake directives. I don't want to go off forever on how these work. There's like 2 entire YouTube demos of at least 2 hours length that tell you how these work. But now if you go back, it might be slightly confusing because they're named differently. So we used to have this directive called bake that would take a polymorphic procedure like this and fix the value of t and give you back a non-polymorphic procedure. Or if it had a lot of variables and you only baked some, it would give you like a less polymorphic procedure back, right? Now we call that bake constants because bake was just a very generic word and it invited confusion. So here, I'm going to say G is what you get from baking constants on F with t being float, right? So we're going to say, we're basically making a new function where instead of $t, we just say float. And then we're going to call that on a float, but also on an integer literal, which, you know, the language semantics are that integer literals will cast to float implicitly. And so, where are we? When we call this, it says x is whatever the value is, and t is whatever the type is, right? So here x is 3.0 and t is float 32. That's no surprise. In this version, x is 5.0 and t is float 32, right? And that's because we baked this as float, right? And we're calling the baked version. Even though that we're calling it with an int, it's not polymorphic anymore because we squeezed the polymorphism out. Now the other version of bake that used to be floating around used to be called bake values. And that's confusing because these are also values. The polymorph variables, you're assigning values to them, right? So this is renamed bake arguments. And, you know, so I can bake arguments of f with x equals hello, right? And so bake constants bakes the polymorph variables, but bake arguments bakes the actual, you know, parameters that you would pass. We might maybe call it bake parameters. I don't know. That's a little bit of a longer word, I think. P-A-R-A-M-E-T-E. It's 1 letter longer. It's 1 syllable longer, too, so that's important. Anyway, so I'm calling h, well, I'm saying h is f baked down, so its only argument is hello. That gives me a procedure with no arguments, right? If you're from the functional programming world, this is a compile time version of currying, right? So it's like we're currying this down and generating a new procedure, but we're doing it at compile time, right? So now I can call h, and when we do that, we say x is hello, and the type is string, right? So that all works the same as it always used to work. We just got less confusing names. Now, one thing that we had overlooked in previous functionality, and that didn't work properly prior to today, actually, is that in this case of currying h, we baked both x and t, right? Because when you bake this argument x, because it's polymorphic, you also have to fix t, or t would be like undefined, floating off in space. So t has to be string because the value of x is string. So, you know, when you do this, it actually bakes both variables, but this wouldn't have to be polymorphic, right? You can do this on a procedure that's not polymorphic, and it works fine as well. This is just a more complicated case. It's a more show-offy case. Okay. In addition to that stuff, why not call it bake types instead of bake constants if that's what it does? Because the constants don't always have to be types, right? In procedures, they're always types. maybe I should have demoed that. Where are we? So here, because the only things that go into the constants block of this procedure are on the right, and the things on the right are only types. Actually, that's not true. Okay, indirectly. Anyway, here they're types. If you make a struct, like if you go up to this thingy up here, right? Thingy takes an int parameter, right? And you can bake that. And that's not a type, right? So you can bake an integer into that. And in fact, your procedure could take a thingy of 2 variables in the declaration, and you could bake that variable, right? So it's not only baking types, it's baking constants generally. Basically, yeah. Maybe someday we'll do another stream on that if it's worth going into. Okay, people are still asking questions about that in chat. Maybe we'll get to it at the end. There's a new directive to deal with overloads, right? So if I only have a procedure and there's no overloads for it, it's just one procedure, just like you would use back in the days when we used languages that were no overloads, you could just assign the value to a variable, right? And here I'm using type inference, so I'm not being picky. I'm just saying I want factorial, and then I'm printing that, and the result of that is exactly what you would think. Well, it's a procedure, and there's the pointer value of the procedure, right? But if there's an overload, you can't say the same thing, right? It won't work because we don't know which one you mean, right? So if I do this again, it'll be, let me take off the no color. It'll be like, well, you're attempting to assign a variable to an overloaded procedure. You can't do this. Maybe I should tell you where the overloads are, but we don't right now. In this case, we're fortunate they're right here. So in C++ and similar languages like that, the way that you would do this is by using the type, right? You would declare the type of var2, and then the casting would basically do the selection of overloads. And that's fine, but it's very cumbersome to write the types of these things. And they can be arbitrarily complex, right? If you've used C++ and had a procedure taking 2 arguments that are templated, one of which is a template taking other template taking a type argument, it can get so bananas that you really don't want to do it, right? So I came up with a thing that's kind of fun, which is this directive called procedure of call. And the way it works is, look, it says, give me the pointer to the procedure that I would get if I were calling abs of f, right? And here for b, give me the pointer of the procedure that I would get if I were calling abs of I. And you, compiler, you work out the types. I don't want to say what the types are. I don't want to think about it. I also don't actually want to call these right now. I just want to get this procedure so I can store it in a pointer in memory or something, right? And you, compiler, do the overload selection and work it out, right? So here we're getting abs A and abs B, and we're printing out those pointers, and you'll see that they are, oh, whoops, I got to run again now that we compile again. These pointers are different from each other because they're the 2 overloads, right? Now these tell us whether we're calling the int version or the float version, right? So down here, we're calling both of them with an autocast on -1.0. We're calling abs A on autocast -1.0, and abs A is the one that we called with a float argument, right, f. So we get the float version calling abs float, and abs B is the one that we got by calling integer. And so when we do that, we get the integer version, right? So this is a way of not losing the power of being able to easily and briefly talk about procedures once they become overloaded, right? You still can handle them nicely. Now this works on polymorphics as well. And it works on polymorphics with overloads, right? So here's 3 procedures. They're all called poly, so they're overloaded. 2 of them are actually polymorphic and 1 isn't, but it's still called poly because I want it to be overloaded with the others. And we're going to use procedure of call to sort of give us whichever overload applies to these arguments, right? So here we're going to do one that takes an array as the first argument, so that's going to be this guy. And here we're going to do one that takes a pointer to a string as a second argument. So that's going to match this one because this one takes pointer to anything, right? And the third one is going to be something that takes a string, right? Greeting is a string that we define here, and array is defined here. So we're not actually calling these again yet. We're just saying, give me these procedures. And then, of course, we're just calling them. So we might as well have just called them. But really, you can do anything you want with the pointers. You can put them in a hash table, store them, call them later, pass them off to a library, right? Whatever you want. So, this is just to show that these work. So where are we? So we get poly array colon hello poly a x is whatever because we're printing out the value in here. I'm not going to tediously go through this, but you can convince yourself by pausing the stream later that this all worked and called the correct thing. There's some nuance here. For example, when we do polymorphism in general, everywhere in the language, not just in this case, we do a little bit of tweaking to types, right? So for example, the type of this array, we print out the type of this array down here. And it's an array of 5 S64s, right? It is very specifically an array of 5 things. But when you polymorph a procedure generally, we sort of figure you don't really want it specifically for an array of 5 things. You just want it for an array of things because you don't want to bloat your program out to like 10 zillion procedures by calling this all the time, right? The nuance here is that when we print out the type for the and the value for the type that takes an array, it's actually an array of unknown length, and then when you print out the value, it's 5, right? Because the polymorph system tries to be very not pedantic about what the type is. Now, should you be able to have an override about that? Maybe. There's not a way to do it yet, but eventually maybe. We haven't found a situation in which we care that much yet. Anyway, so this is just all calling all of these. You can have fun in the video later if you want. That is everything that I wanted to show. Wow, okay. So we got through that in just a little bit under an hour. Does procedure of call result in a failure compiler error if it doesn't exist? This may be useful in metaprograms, but wouldn't be strictly needed. It will error. So if I do this and go bleh, right, then bleh. Okay, but in metaprograms, you wouldn't exactly want to do this anyway. You would just look up, in metaprograms, you get messages for all the procedures. So you just look to see if there was one of the name that you wanted. And if it wasn't there, then it wasn't there, right? So that use case is already covered. Will procedure of call give you the same pointer as using bake constants with the same types? Yes, because the polymorphism system deduplicates procedures of the same type, right? And both of these go through the same core system. Anyway, you can invoke procedure of call foo of bar without creating the throwaway variable bar. Well, if what you mean is without a runtime impact, so I put variables in here just because I felt like it, but this works just fine. Like if I want to do this, right? That works. So I just wanted to give you guys a slightly more complex situation. Whoops. And that would certainly generate no code whatsoever in debug or release builds, right? Because there would be no declaration. Here in debug build, you would get a declaration and assignment, but in release build, that would be hopefully optimized out because nobody uses them. But yeah, you just need to put anything in here. It doesn't have to be a variable of any specific kind. Okay, those were the specific procedure of call questions. I'm actually going to end the main presentation here. I'm going to take a 3 to 4 minute voice break, and then we will come back and answer general questions. For those of you who are not too familiar with Twitch, you can address questions to me. Address whoops. Okay. So you just put that in the question line, and I will see it. It gets highlighted to me. I need to get some cough drops and whatever. That's not a very good Y coordinate. Okay. Yeah, whatever. Okay, resuming in 4 minutes. Time to pop a cough drop. Sure have lots of questions. Oh boy, there's a lot of questions. Oh, that's not a good color. Oh, because of the alpha. That's also not a good color, but this is what it is. Oh my God, there's so many questions, and they actually look like they're mostly on topic. Okay. So, okay, we take a bunch of things from functional languages. Do you see it beneficial to bring other concepts like higher-kinded polymorphism, pattern matching, etc.? The answer is probably not. This is a language for people who write systems level and embedded applications. And the philosophy is that generally you're close to what the machine is doing. Even when you have very high level, powerful constructs like polymorphism or, just being able to use types as values. When you do that in this language, you know what the CPU is doing, right? Whereas once you get off into this other stuff, you don't know what the CPU is doing. And so we're definitely, I am not the biggest fan of C++, especially these days, but the reason I still use it and the reason my entire industry still uses it is because certain things are true about it. And that's one of them. And I don't want to break what isn't broken, right? Don't want to fix what isn't broken. Hold on, I got to crunch this cough drop. Do the bake directives generate new functions or just parameterize the baked constants arguments under the hood? If the former, does this work? Procedure of call, bake arguments f of x, y, and z. Okay. Yes, they generate new procedures, completely different, completely precompiled procedures that don't call out to the old procedures. That is how that works. The thing that you said about procedure of call, bake arguments f, x, y, z is not really syntactically correct either time. Like, I'm not sure what you're trying to... The thing that you're doing... I think you have to think more about what you're doing because it's not clear to me. Like, procedure of call requires a call and bake arguments requires a call. And so you would need two calls in your syntax, but you only have one. So maybe think about that and re-ask, because I don't know. Any possible optimizations to be gained from being hyper-specific with polymorphs? Well, for sure, one of the things that we plan to do a lot is bake procedures. Like, say there's a Boolean argument that controls a bunch of if statements in a procedure. You can bake those if statements out, especially if they're static ifs, right? You could write a procedure, well, and in fact, you can put the $sign in front of the name, which, as we've demoed before, is auto bake, right? And then you can call that and it'll auto bake a version with true or a version with false. And of course, that's combinatoric up to however many parameters you want, right? So it's a way to get around this thing that you do in C or C++ of like copy and pasting different versions of a procedure or if-defing things out and recompiling several versions. You don't need to do that here. It's a much cleaner and higher level way of accomplishing the same task. So yeah, we've already done a little bit of that in the game and we plan to do a bunch more. Can you easily set different optimization levels, warning levels, etc. for code files in a build? We don't do it for separately different files right now. That might be something that we could do later. Right now, you can set all those things for the entire build or not. But here's the thing. So you asked about warning levels. Warnings, in the compiler, there are not very many warnings because I do not like the warning culture of C and C++. I think it's pretty terrible the way that's worked out. there are warnings that you saw today because of the use of that type directive, but those are temporary just for the use of our team, right? In like a week or two, once we've scrubbed all the old type directives out of the code, those warnings will go away. So there's really not very many warnings in the system. And the reason for that is because the plan is that you as the application programmer have the best idea of what kind of thing you want to be warned about. And it could be quite a sophisticated thing that you need to write a little mini program to detect. It may not be something that the compiler knows how to look for. And so the idea is that your metaprogram has a bunch of house rules and that you can generate whatever warnings you want from that. And those can be as controllable as you need. And those can be controllable not only on a per file basis, but on a per procedure or per line basis. And we have demoed that in previous demos, and those are available on YouTube. Will print procedure be able to print the signature instead of the address? Yeah, it will. We just don't do that right now, mainly for terseness. Like there's this whole question of like, if you print a struct that has pointers to substructs and all sorts of things, like how deep do you want print to recurse in giving you all that information? I don't exactly know. I feel like we may end up passing an argument to print that controls that. We didn't do that originally because we didn't originally be able to pass arguments after varargs, but now you can. So you can have a varargs procedure that also takes a control argument after the varargs. Therefore, the control argument is optional. And we could probably say like verbose or something. And if it's verbose, it would give you the type of the procedure. Or, you know, maybe it's a whole word of like control bits or something. You know, comments welcome. Actually, let me put up email longer questions, comments to language. Oop, not Calm. Okay, that should go up a little bit. So this is maybe not the best font to draw this in, but you know, this address here, let me switch to this. This address here is not a mailing list. It is just a thing that I read, doesn't go to anyone else. I don't promise to reply to most things because I can't. We're busy working on the language, but we do read everything. So if you have comments that you don't feel are appropriate for Twitch chat, you can send them to this address. Do I have a different font loaded? These are all ugly fonts. Let's try Sans. Ugh. All right, we're going to stick with this. Okay, more questions. What does the tilde do? I saw it up with the polymorphic stuff. That is a relative pointer designator. If you go on YouTube, there is a channel of compiler demos. Let me pull it up. There is a playlist. This demo and Q&A will end up there later tonight or tomorrow. God, they keep changing the stupid interface. So we have a playlist called A Programming Language for Games. We're probably going to have to rename it because it's not really just for games at this point. The original things on this playlist are old. I don't really recommend watching the first couple because they don't have that much relation to what's in the language now. But you can see there's all these demos in here of official things. And one of these, here we go, is the relative pointer demo. And this one starts using the tildes like you see up here and so forth. Some of the syntax is different, so the $ syntax is much shorter now and stuff. Wow, I look tired during this demo. But yeah, relative pointer demo. In case you've already specified that the argument should be an array of unknown length, I guess the same thing happens when you pass an array to a bare $t. Yes. Yes, the polymorphism system does that minor type simplification. Will that fancy error highlighting extend to custom errors? Yes, so the syntax tree has all that bound information. So yes, you can print out the same bounds that the compiler does. I should have mentioned that, but didn't. If you're going to start releasing documentation, does that mean that the syntax has settled down? No. We will update the documentation as the syntax changes. It's just the syntax probably won't change before the initial closed alpha. And we want to have documentation for that, for those initial users. And so why not make it available a little earlier, too? Can you chain metaprograms, i.e. metaprogram gets built by another metaprogram? Yes. You can do whatever you want there. I think we demoed that at some point. Not related to this demo, but when you import or load, does the imported file get imported into the current scope, or does it get imported into a namespace? This may change a little bit soon, mostly in terms of giving you more flexibility, but right now, what happens is every file gets its own file scope, but then has the ability to export things into global scope if it wants to. So it's still kind of flat right now. One of the next features we're going to do is sort of more structured library support. So libraries will have their own namespace, and we're just going to work out exactly how that happens. But yeah, that'll be the next thing. Would I consider working on some more complex metaprograms to demonstrate, validate use cases? Yes, I would consider that. If you go back to that YouTube playlist and look up the compile time execution workspaces, there's a number of demos that show hours of more complicated metaprograms. It's all there for you. You're not clear on why the two different versions of bake exist when the baking two behaviors could be per argument. Could you explain the reasoning in more detail? The reasoning is that there's actually two different namespaces for those things, right? The names of your arguments are not the same names as the names of your polymorph variables, and that means, in principle, even though it's kind of a bad idea, you could use the same name both times. Although it's hard to understand why you would sensibly do that. So it's just set up that way right now. Maybe it's the case that we just want to simplify the world and only have one version. That might be true. You know, as we continue working with the language, one of my primary motivations all the time is to simplify things. And so that would be a thing. It's a thing that I've thought of before, and it's a thing that we may do. I just don't want to simplify prematurely before we have experience using this feature, right? If our experience tells us, yeah, we never really want them to be separate, let's just combine them, then that's fine. But I would rather be precise about what we're doing in the short term and then see how it goes. I'm going to skip questions about next projects. We're staying on topic for programming language. I haven't seen any use of string templates, and I'm not sure if you have discussed it before. I'm curious to know what your thoughts on string templates are and whether you've considered them, like in C#, Kotlin, Groovy, Python, Ruby, and many other languages. If you have considered it, is it just a thing that doesn't fit with the design patterns of this language? I'm not sure what you mean by string templates, but do you mean something that produces a string that is then compiled by the compiler? Yeah, we have that. We totally have that. Go on YouTube, look at the polymorphism demos, and look for the body text directive, which we have. And then also at compile time, you can use a thing called add build string, where you just synthesize a string and add it, right? We've done both of those tons. You just have to go look at the demos. Wouldn't it help to highlight error or warning on the message? Maybe. It's a minor tweak. We'll see. I just don't like fruit salad, so I'd rather just put the highlight on the thing that you want people's eyes to track to, right? If you see red, you know there's an error. You don't need the string error exactly to tell you that there's an error. So if you see red, it's like, oh, that is the error, right? What's the thing I'm using for the resuming in 1 minute message? That is a slideshow program that I built in this language. It's a pretty simple program, but you know, I use it to do slideshows. This was sort of our test slideshow that isn't really meaningful that we use during development. And I just flipped to the last page and changed the slide on the fly. If bake constants and bake arguments are separate keywords, can you bake argument 0 and type 1 at the same time? Right now, the answer is no. You can do that in 2 subsequent steps. Again, it may be that by experience, we find that we want to do that and we find it a little bit of a headache, in which case that would be another reason to combine both of those into one thing. When doing currying of function arguments, is this like functional languages and you have to do them in the order they appear? No, you can do them in any order you want. Do you have an idea of when you'll be starting the limited alpha release? I don't exactly have a strong idea. My vague idea is by the end of the summer. But we don't know for sure. It's just going to be a matter of when these next couple of features are done, because these 2 other features are very important in terms of how you would write code. But once they're in there, I think we're ready. So 2 more big features, if I'm not forgetting anything. What is the comparison of this language to Rust? No, it doesn't sound just like Rust at all. Rust is focused on safety. This language is not focused on safety, and that changes tons and tons of things. Tons and tons and tons of things. Again, if you go back and you watch some of the demos, we're a completely different language than Rust. Completely. In C and C++, arguments can be evaluated in any order. So like f of a of 1, b of 2, b2 can run before a1. Is that true here as well? You know, we can always change these decisions, but the decision right now is that yes, it's true here as well. You sort of want your arguments to be able to evaluate generally simultaneously, you know, not threaded style simultaneously, but like, you know, you want to be able to mix the instructions among each other for good pipelining and stuff. That's just a thing. So yeah, don't depend on order of procedure argument evaluation. What kind of skill levels will you be catering to on release? Would beginners still be able to follow tutorials to jump in, or would the tutorials be more focused on showing the features? I definitely would like to have tutorials that you can follow, but I don't exactly know how understandable they would be to non-programmers, right? Like if you've never learned to program, I don't know if we're going to be teaching you how to program, right? If you know how to program, but are still at a beginner to intermediate skill level, then maybe it's fine, right? We just have to see. You were basically trying to get the procedure of call to a baked procedure. Yeah, so you could do that. So if you have an expression that is like bake whatever, and then say procedure of call of that with some other thing, yes, you can do that. Most of the time, that wouldn't be that useful because often the baked procedure will be the procedure that you want from procedure of call. But sometimes, like I said, you can bake only some of the polymorphic variables out of the baked procedure, and then procedure of call would give you the rest. I don't exactly know what use case would naturally generate that pattern, but there might be one. Is $x:\bool considered an argument or a constant when baking? Right now it is considered an argument, even though it's a mandatory argument. The reason we do that is because there's a version of that where you say $x:\bool, which means, well, maybe pre-bake this if it's available as a constant at compile time, but if it's not, then don't pre-bake it, right? And in that case, we don't want the handling of that to be much different from the handling where it is mandatory. So we make those the same thing. We'll see over time if that's the right decision or not. Is it possible to declare a procedure pointer along with an overloaded procedure right in the declaration where you definitely know to which overload you'd be referring to? Essentially just assigning the func to both a variable and a pointer in the actual declaration. I'm not sure that I visualize what you're asking. You'd have to give me a more concrete example. I'm not picturing it. Threads are difficult. It'd be nice to wrap code with directives like fork. Any thoughts? Well, what do you mean by fork? Do you mean to do threading for you automatically? We're not really looking at stuff like that right now, but what we are looking at stuff that makes threading a lot less error prone, right? The most basic kind of thing would be an equivalent of thread sanitizer from LLVM, but there's other things as well that'll be helpful with threading. It's going to be a while before we do those, and those probably won't be until after we do the limited alpha release, because I don't want to hold it up for that stuff. But it is in the roadmap. Threaded programming is very important, and I don't think that procedural languages these days do very much to help you with that, and they can easily do a lot more than they do. Are you able to swizzle reuse print arguments? Yes, and you can do it exactly like you're saying with the %2, %1, %3. In fact, we had that during today's demo. If I go back to this and say %3, so here I'm just passing red, green, normal as 1, 2, 3, and I'm using 1, 3, so that's red normal, and then 2, 3, so I'm using 3 twice, so that's green normal, right? And then 4 is the first thing, and then 5 is the second thing. So yes, you can do that. And that is good for cases like this, but it's also good for internationalization where you may want to reorder the arguments and so forth, which, yeah, have fun doing that in C++ without building a whole separate system. You'd like to add whether you could declare a pointer to function type directly in the overloaded decal. You mean as one of the parameters? Yes, you could do that. Yeah, but you can do that in C or C++ as well. Like, that's not anything crazy. Do I have any thoughts on language evolution after the release? Sounds like the compiler won't be open sourced. How do you see the process of building the community around it? Well, we're going to kind of wing it. I don't know about long-term evolution. I've said we're not going to open source it initially, but that's only initially, right? After some period of time, we will open source it. It's just that the style of development that I want to do once we initially have an initial body of users is not much different from the style of development we're doing today. I don't want to transition very early to some kind of like cat herding, open source, patch rejecting, tons of email spam every day situation. I don't think that that is conducive to rapid work or delicate design decisions, right? And so my goal is to make the best language design that I can. And part of that involves observing what happens when the current design meets reality initially and then tuning based on that. So that is still going to be done in a design chef kind of way. In the farther future, we will open source it, yeah. What's the plans for debugger? Well, you can debug today on Visual Studio or in LLDB or GDB. Long term, I would like to make our own debugger or at least some kind of program visualizer understander tool, but we haven't done it yet. And we've got a lot of things to do in the short term, so we won't do that anytime soon. Thoughts on a read-eval print loop? I do not think read-eval print loops are very useful. I don't know why functional language people like them. I thought they were cool when I was a freshman in college, but even by the end of college, I was like, yeah, this is kind of stinky. I don't understand why people like them, frankly. And the reason is because you can only do toy things in a read-eval print loop. Like, it's just not real programming. Idea, write the documentation as a metaprogram that executes the code examples it contains. Yeah, maybe. I mean, I just don't want to be absorbed so much in that conceit that we put people's attention where it's not needed. Have we thought about Godbolt-like capabilities like, hey, show me what you generated for this procedure? In the long term, I want to do that. In the short term, it's just sort of out of scope, right? We want to get a good working language first. But yes, ideally, well, I'll just say to date, one of the strong feature sets of this language has been the ability to introspect on your own program to a greater degree than you get with other languages and with more ease than you get with other languages. So something like that, something like show me the assembly that was generated for this procedure would be a natural extension of that, yes. Other than the array length elision, is there any other example of type simplification that polymorphism does? There might be. I'm not thinking of one off the top of my head, but there is another type simplification, which is if you're using relative pointers and type inference, then we ditch the relative pointer qualifier. So for example, if I've got a struct and I've got some relative string, string tilde s16, right? And I've got some s, right? And now I don't know where that came from. A procedure returned it to me. And now I'm going to say name is s.name, right? So this is a problem because this is stored somewhere very close in memory to this because it has to be reachable in 16 bits, right? But that may be very, very far from the stack. So if I just copy a 16-bit relative pointer string, I'm going to very likely overflow my pointer. So in this case, when you don't declare a type here, this becomes string, right? It's not string tilde s16. And that's just to make relative pointers usable. If in a very, if you want to get very pedantic about making absolutely sure that you have the exact same type for some reason, you can do this, right? And because you're not using the automatic type inference, you get exactly the same type, right? what CI service are we using? We're using the frickin' Microsoft thing that we don't like very much. Someday we should rewrite that. What's it called? I don't know. Oh, that kind of string template. No, we don't do that. You can do that with metaprogramming, but we don't do that. It's also called, you mean string interpolation. No, because lots of reasons. It's bad for internationalization is the main reason. Tim Sweeney was trying to convince me that it wasn't bad for internationalization, but maybe I have to talk to him about it again because no reasons stuck in my mind, which means maybe he didn't convince me. You're colorblind. Thank you for the no color option. Yeah, well, we'll also add color control. So you could pick colors that are not a problem for you personally. Oh, no, different people are meaning different things by string templates. So Ninja Pretzel is talking about string interpolation, which we don't do. Alex Couch is talking about string templates where, oh, maybe it is string interpolation, just more complicatedly. Yeah. No, we don't do that. I don't like it, basically. If someone wants to email to this address and explain to me why string interpolation is good and why it's not bad for internationalization and why it's not bad for, program understandability, then let me know. I think it's pretty bad, though. What are the two more big features that are required for the alpha release? One, I have already mentioned this Q&A, is more formal library support. Two is a macro system that will not work like the C preprocessor. It'll be more like Lisp macros, but not in the style of Lisp. It'll be in the style of the metaprogramming that people have already seen from this language. And then that will have consequences in terms of how other features are implemented. How do I keep myself from burning out while juggling these projects? Well, first of all, I find that when I work hard and get a lot done, it actually makes me more motivated, right? The thing that depresses me and makes me less motivated is when I feel like, just there's so many problems and this goes forever without progress and whatnot, right? So first of all, actually cranking hard makes me motivated, and then take a break, right? Secondly is just by this point, I have a lot of experience doing large projects that are very complicated, and I just know how it goes at this point. And my brain understands it and doesn't freak out as much. Probably if you go skydiving several times, your brain starts to freak out less, although I'm not a skydiver, so I don't know. Thirdly, methods of psychology management are very useful. For example, meditation, but not necessarily only meditation. Andrew Russell is saying not having specified order of evaluation for arguments is not a good plan. I disagree. That has literally never been a problem for me in C++. Literally 0 times in my entire programming career. If you want to email to this address and tell me why it's a problem, maybe we'll have a discussion about it. But literally, I have been programming in C and C++ since 1991. So 27 years. I have had that problem 0 times in 27 years. So if you're going to convince me that it's not a good plan, you're going to have to explain why. Can we get some exposure to the basics of the game engine? Well, there's been a bunch of streams. So when I showed that playlist of demos, there's also a playlist called Game Engine Programming. Let me show that. Right. My channel. Creator Studio might get me there faster. Video. Where's the playlist? Why does YouTube keep moving the playlists link? Frickin' there it is. Okay, so one of the playlists is Game Engine Programming. There are 40 videos in here, and I go through different topics where I implement different things. Animation, drop-down console, controlling the animation with like an animation graph usable by an artist, right? Metaprogram, oh, whoever was asking about metaprogram functionality, checking print calls is part of that. Editor, in-game editing UI, the testing system. So you can see many things about how the engine works there. Just go to youtube.com/playlist/?list equals blah, 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 or search for it. Probably better. Do string literals act like in C or C++, where you concatenate two strings at compile time by literally putting two literals adjacent to one another? No, we do not do that. If you want to do that, though, you can use a run directive and concatenate them. And because you're using a run directive and invoking compile time operations, you can do whatever you want. You can rot13 a string at compile time and glue it onto its non-rot13 counterpart with arbitrary joiners in the middle, and then you can uppercase it. Nobody cares. You can do whatever you want. It's way more powerful. Rather than add templates as another feature of the compiler, wouldn't it make more sense to make metaprogramming easier and quicker to use, or at least have an easier subset to accomplish something like this? It seems that as you add more and more features, the language becomes cluttered, not as elegant. The language is still pretty elegant. Like, it's just that you're not familiar with it, right? If you were familiar with it, it wouldn't seem very complicated. It's tremendously simpler than C++, crazily simpler than C++, and yet it's also more powerful than C++, so there's that. But I understand, if you're just sitting on the outside and just seeing these things once in a while, it may seem complicated. Adding more metaprogramming features is all well and good, but the thing about metaprogramming is it's harder to debug than straight up programming. So metaprogramming is powerful, but I don't think you want to do everything by metaprogramming. Maybe I'm wrong about that. And one possible future for the language is that we do the initial releases and then we find out more and more ways to implement things that were built into the compiler as user-level libraries instead that use metaprogramming. And I would be fine with that. I like simplifying things. But I don't want to assume that that's going to be the way it is, right? There's other reasons to do that. So for example, when features are built into the compiler actually knows what's going on and can give you much better error messages. Whereas if just a metaprogram's doing something and it's generating some desugared output that then the compiler compiles and then that's wrong, the error messages are often going to be really crappy. And the difference between those two things can be an hour a day of programming time, right? And that's a tremendous friction. So I'm making these decisions carefully, which is not to say that they're not right, or not to say that they're not wrong. I mean, it's not to say that they are all right, but they're the best decisions that I have. Again, if you have a counterpoint, you can email it here. Can you bake varargs? I believe so. If not, we'll make it work. Enemy Mouse is back explaining his thing. I'm imagining you are declaring an overloaded procedure, and in the course of doing so, you also generate a pointer to that procedure and a type of said procedure all in one shot at the original procedure declaration site. I see. Maybe there's a way of that happening, but I don't know of it, no. What kind of things can you put notes on? I've seen functions and maybe structs. You can put a note on any declaration right now. And then the way notes get onto procedures is they actually flow from the declaration onto the procedure. But they're technically on the declaration, which is a different thing. Is there any facility for Doxygen style documentation generated from the code and comments automatically? Dude, I hate that stuff so hard. I never understood that. It always seemed like the most useless thing in the world to me. If you find it useful, great, but like, ugh, right? That said, there will be something that gives you a summary of what the procedures are that you can call in a library or in the main program. And there will be something that gives you descriptions of those if the programmer provides that, right? I don't think of it so much as a Doxygen style thing as much as, like, if you know how Lisp or Emacs work, where, you know, in the declaration, you can provide a short string that tells people a little bit about how to use it. That's fine. But most auto-generated documentation is terrible. Like, I don't understand. Not only is it not useful, it's just soul-killing to look at. Part of me died when I first saw that and people were trying to tell me how great it was. I was like, what? What? But maybe it's just part of my brain that doesn't work like other people's brain. I don't know. When you do the work on parallelism, would you consider an SPMD model like is used in languages such as OpenMPI or OpenCL? Maybe eventually, but that's not my concern initially. My concern initially is to make very basic working man's parallelism much easier to do. So just stuff like, man, I've got a mutex and I want to make sure that I only access this variable from inside the mutex. Or like, you know, here's an integer on a struct and I want access to it to be atomic, right? That kind of a thing. All this more frou-frou stuff we can deal with later, but that kind of stuff, given the aforementioned help, it's much easier to write your own job system or whatever that'll kick off the same procedure 20 times in different threads or whatever. Yeah, so the as colon equals assignment in this language doesn't work like in C++. You're only allowed to have one on a line. It's not an expression. So yeah, you can't do that, and that's by design. Do I know which versions of Windows the binaries we produce would run on? We're trying to minimize dependencies. We still depend on libc right now, so it would depend on like what dependencies that libc has. But the goal is to eventually be off of that, right? On Linux, we still have to depend on libc because as far as I know, you can't not do that. Maybe I'm wrong about that. But on Windows, you certainly can build an executable that only requires kernel 32, for example. So it's pretty important to people who make games to support versions of Windows as far back as possible. And we're always in some kind of passive-aggressive fight with Microsoft about that, because Microsoft seems to always want to like sneak dependencies into the latest crap in the newest version of Visual Studio. I don't understand why they're not more careful about that. How is SIMD done under the hood? We don't do SIMD yet. It's just not in the design yet. We'll think about it later. Going to be curious to see how the macro facility ends up being different from your existing metaprogramming to warrant doing both. I think it will make sense when you see it. But as always, if experience leads us to understand that one of them is unnecessary, then we'll take it out. Dude, I have no problem spending months of work on something and then taking it out later. Like, in my opinion, that's part of how you make things good. So that's just how it is. You're making a game in C that you want to translate down the road. Do you have any suggestions on how to develop now that'll make that smoother? Not really. I mean, if you're in C, there's not going to be much that you can do that you won't be able to do here. I mean, maybe if you're doing really weird stuff involving lots of nested macros, because we don't do a text preprocessor, that probably wouldn't port over directly. But if you want a text preprocessor, you can insert one in the compile pipeline and it'll work fine. So even that's not a showstopper. Does this language favor immutability by default? No, not now. Although we're thinking about whether something like that is helpful. At some point, if ideas like that are not that proven, then we might as well just do version 1 of the language without them and see if they make sense in version 2. Doxygen might be a bad example. RustDoc is really the example I like. Yeah, I've never seen RustDoc, so I don't know how that is different from Doxygen or how that makes it better. Were there any big announcements? No. We did not announce that we are releasing a Roadster that drives out of the back of a truck. What do you think of the idea of assembly of that would return the bytecode of a given procedure? I think that would be cool, as mentioned earlier. Is SOA to AOS still in the language? Eventually it will come back. Yes, it is not in right now. You think I said the current engine is GL-based, given my comments about Apple's deprecation of GL? Are we stuck behind a Vulkan port? No, what you will be stuck behind is an engine that has different backends for different platforms, probably. And I don't know if one of those will be Vulkan. Maybe. We'll see. But that'll actually be more educational because it'll be closer to how real game developers release games anyway. You don't need libc for Linux. You can issue the syscalls yourself. Okay, so maybe we can get out from that dependency as well. Oh, they're architecture dependent. Maybe that's not so appealing. If they're architecture dependent, I don't know. I don't know, man. We'll see. How do we handle copy versus move semantics? There is no such thing as copy versus move semantics. There is just copy semantics, just like in C. I think that whole thing in C++ is part of a giant, giant, giant disaster. I don't know if we will eventually add move. I don't think so. If we do, it'll only be if I'm convinced it won't be a disaster. We certainly will not add references if I can help it. Famous last words. Who knows? Who knows what's going to happen, but yeah. Have you seen the Mike Acton Unity talk where you can tag the data streams? I didn't see that part of it. That seems like a cool idea. Google has a single include file thing that calls Linux syscalls on a few different architectures. That's good to know. Okay, thanks everybody for coming by and staying all the way through the Q&A. I'm going to go out and get a well-deserved chocolate bar now for my last-minute programming that finished the features for the demo. Who knows? We might live stream later tonight because I want to do some compiler cleanup. Thank you for coming by. What do you think about giving a stack trace when you crash? We already do that. And like I said, I'm hoping the next demo will be a bigger feature. We'll see if that's true. If enough time goes by without the bigger feature being done, I might do another one like today where we just recap the smaller stuff. We will see. And if you missed all or part of this demo, it'll be up on YouTube soon, within 24 hours. Good night, everybody.